what if the next leap in solar power wasn't just a lab experiment, but already rolling off a production line? Oxford PV, a UK-founded startup, has developed a perovskite-on-silicon tandem solar cell that has the potential to deliver more power than conventional panels, and they're amongst the first to manufacture them at scale. The tandem cells consist of a layer of perovskite, a class of materials known for their excellent light absorption and ability to convert sunlight into electricity efficiently, on top of a standard silicon solar cell. Perovskite can absorb a different part of the solar spectrum than silicon, allowing the two layers to work together to capture more energy from the same amount of sunlight. Unlike other perovskite companies still in the research phase, Oxford PV is already shipping commercial modules with an efficiency of 24.5%, and they've reported achieving a world record efficiency of 28.6% for their commercial-sized perovskite-on-silicon tandem solar cell. That's about 20% more energy than today's standard silicon panels. What stands out to me is not so much the efficiency improvement, so much as the fact that they've managed to scale up production while maintaining stability and durability, which are the major challenges that are standing in the way of perovskite solar cells reaching their potential. Oxford PV's factory in Brandenburg, Germany is now producing these next-generation solar cells at commercial scale, which are being sold worldwide. Customers include major utility-scale solar developers in the US, as well as partners in Europe looking to deploy high-efficiency panels for grid-scale energy production. The company is also working with manufacturers to integrate its technology into residential and commercial solar systems. There are still challenges. Mass-producing tandem solar cells at scale while keeping cost competitive with traditional silicon panels is difficult. Their Brandenburg factory is described as commercial scale, but it's still very small and immature technology compared to the huge Chinese PV factories that make most of the world's panels today. It is far from certain whether they'll ever be able to compete, even if the efficiency continues to improve. And while Oxford PV has made good progress in improving perovskite stability, the long-term durability of these cells in real-world conditions is still being tested. But as more projects install and validate this technology, its potential impact could be significant. And this UK-born innovation, now being deployed globally, is a rare example of a country outside of China establishing a foothold in large-scale solar cell manufacturing, an industry where China absolutely dominates currently.